In this video, I'm going to talk more about what weighted moving average is. In the previous video, we discussed that if the time series data is available, if the historical data is available to us, we could use moving average method to make a forecast for the future upcoming periods, right? But there's one drawback with moving average method is simply, if you remember from this previous example, what we did is we simply looked at the previous three observations and we took a simple pure average with those numbers and then we used it as a forecast. Well, what happens if we would like to treat the days differently? For example, you want to just say that, hey, you know what, if I'm making a forecast for tomorrow, today's observation is going to be much more related and relevant compared to yesterday's and the days before's observation. Um, so the solution to that problem is going to be very easy. It's because instead of having a pure average, then you could do a weighted average method, okay? And if you do it that way, we call it weighted moving average method. You still have to decide how many time periods you have to go back, and you will have to decide the weights for those time periods, okay? And that's why we have these formulas here. The second one here, it says that the total weights has to equals to 100%, right? If you are using 5 different time observations, for example, the total amount of weights that you can allocate to those 5 different time periods should not exceed 100% or should not be below 100%, exactly 100%. And what you do is you multiply these weight percentages with the actual observations to get your forecast value. Well, how it is being done? Let's go back to our same example, right? We do have these demand data, and let's assume that we are going to make a forecast for week 9 using a 4-period weighted moving average method this time instead of 3. We want to go back and look at the 4 most current observations. But the question is also telling us that use these weights instead of just taking a pure average for your forecast. So traditional moving average forecast by using n is equal to 4 for week 9 would be just simply taking the most current 3 data values, adding them up, and dividing this whole thing by 4, right? The question is basically telling us that, okay, this is just a pure average of these 4 values. Instead, go ahead and utilize these weights so that you can calculate the weighted moving average forecast for week 9. So as I said, instead of taking the pure average, if you implement those weights, again, 50% for the most current observation for week 8, 30% for week 7, 15% for week 6, and 5% for week 5. All you have to do is to sum product. First, you have to multiply these percentages with the actual observation values, right? And then you have to add them together. Your forecast, your weighted average forecast for week 9 turns out to be 20.7. Of course, it's going to be different than this value here. All right, so let's go over quick summaries of moving averages. So these are very nice methods, very easy to implement, very easy to understand, and very easy to provide stable forecasts for the future. In traditional moving average method, what you do is you just take a pure average of the most current observations. You just need to know how many current data points that you have to keep in your storage so that you can use them as your forecast. In the weighted moving average method, in addition to the number of data points that you have to know, you have to also know or decide the weights that you're going to be using in weights allocations when calculating your forecast. There are also some disadvantages with these moving average methods. First of all, you have to store past and data points, okay? What happens if you are making a prediction like in the stock market, making a prediction for each second, right? If a stock is going to move up or down, or uh, maybe nanosecond these days. So it means that if you have to look at like entire like 1 million previous observations, you'll have to store them all. and then you will have to keep updating your storage as the time progresses. And you will see this in our Excel implementation. So what's coming up next is the Excel implementation of these moving averages and weighted moving averages. You will see that moving average methods, they lack a trend. This means that, so they are actually late in catching up the recent trend in the data. So they take some time to respond to the changes historically what just happened. And it might ignore some complex relationships in the data, especially if you have like nonlinear trend in your data set. Moving averages may not be really good forecasting method um, in that case. All right. So the next video that's going to be coming up is going to show you how to do moving average method and weighted moving average method in Excel.